Okay, so in this video, queso, I love queso. In this video, we are giving yourself a graph and we want to write an equation. Okay, so we're going to do that by looking at our attributes, or rather at some of our attributes, and then verifying that the thing that we write actually matches up with our graph over here. Okay, so caveat number one, there can be lots of right answers for your function. Okay, there is more than one correct answer, which is good to know because the way that you're interpreting this might be different than somebody else. But we're going to go through our RATE. R stands for the roots. Where does the graph cross the x-axis? So we come over here and we notice that it crosses at about, I'd say 1/2 would be the x value, the x coordinate where it crosses your x-axis. So x equals 1/2. Okay, so what we're trying to do is write an equation, and your roots give you the numerator, right? Whatever equation is in your numerator, you set that equal to 0, and that gives you your x-intercepts, or your roots. So basically, we want to unsolve x equals 1/2. Okay, unsolve x equals 1/2. So the first thing we would do to unsolve is multiply both sides by 2. Okay, so 2x equals 1. And then our second thing would be to subtract 1 to that side, giving me an equation of 2x minus 1 equals 0. Okay, so we're unsolving in order to find an equation. So we're going to put this as your numerator because your numerator tells you what your roots are. So 2x minus 1 is going to be the equation for your numerator. Okay, A stands for your vertical asymptote. So let's come over here to our graph. We notice that the vertical asymptote goes through positive 2. So x equals positive 2 is the equation for your vertical asymptote. And once again, we want to unsolve this. So we bring the 2 over to our left side so that we get x minus 2 equals 0. Now this one, right, your vertical asymptote comes from your denominator. We set our denominator equal to 0, right? That's what gives you your restriction. So we're going to put that equation down here in your denominator. X minus 2 goes down there. Okay, so that's a pretty good looking rational equation. So let's just go ahead and use our other things to verify. So looking at this equation, what would be my end behavior? Okay, your horizontal asymptote. Right, so this is a neutrally heavy. Right, we have an x on top and an x on bottom. So that would mean our equation is y equals 2 over 1, which is y equals 2. So let's come over here to our graph and let's see. Is our horizontal asymptote at y equals 2? And I would have to say yes. Our horizontal asymptote is in fact at y equals 2. So far, our graph, or our equation, matches up with our graph pretty well. And then the last thing, y is your y-intercept. So if you plug in 0 for x everywhere, we get a y-intercept of positive 1/2. So let's come over here and look. Does it look like the graph crosses at positive 1/2? Sure enough, that kind of does look like a 1/2. So this is verified also. So I would say, right, in my humble mathematical opinion, that this equation is a pretty good equation given the graph to the right. Okay, so I am pretty happy with that. Everything, the E works out, your horizontal asymptotes, your y-intercept works out. So our equation comes from your roots, where it crosses your x-axis, and your vertical asymptote. Right, those are the things that are doing the most work in order to write our equation. So let's see what's going on here with number 2. So I have, go back to R, the roots. My graph crosses at one spot, and that's at positive 1/2 again. Okay, so I have, just like I had before, x equals positive 1/2. And if I unsolve that, again, unsolve it, I'm going to get a 2x minus 1 equation. Okay, so 2x minus 1 is my numerator, because your roots come from setting your numerator equal to 0. So if we start with our roots, that means our equation goes in your numerator. And then we have two vertical asymptotes, 1 through x equals negative 3, and 1 through x equals positive 1. So those are the equations of your vertical asymptotes. And we unsolve, so we bring the minus 3 over to this side, gives me an x plus 3, right, as one of my factors in my denominator. And I'll bring my positive 1 to the left and make it an x minus 1. So from each of your zeros, we can get some equations, right? And since these are two of them, we're going to multiply them both together. Okay, so now we have to do the algebra. Right, we're going to algebra this out. X plus 3 times x minus 1. Okay, so I like to FOIL, right? X times x is x squared. X times minus 1 is minus 1x. And then I have 3 times x, which is a plus 3x. 3 times minus 1 is a minus 3. Okay, so we're not going to leave the a as a factor. We're going to make sure to multiply everything out so we have one standard form equation. Okay, which in this case becomes x squared plus 2x minus 3. Okay, standard form for your quadratic. So let's check everything else out now that we have those two things. So we've noticed that this function is bottom heavy, right? The degree of the denominator is a 2 and the degree of the numerator is a 1. So we have a bottom heavy graph. So all bottom heavy graphs have a y equals 0 horizontal asymptote, right through the x-axis. So let's come over here and look. Sure enough, we can see that there is a horizontal asymptote that goes through the x-axis. Okay, so that part checks out, right? We verify that that is indeed true. Okay, that works. And then if I were to plug in 0 for my everything, every x, right? 2 times 0, 0 squared plus 2 times 0 minus 3, I would come up with a y-intercept of 1/3. Okay, so let's come over here and see if we have a y-intercept of about 1/3. And I would, that's pretty good. Pretty good for a 1/3, maybe 1/4, I don't know, but I think 1/3 would be sufficient for that value. Okay, which means my equation that I wrote to begin with is a pretty good equation. I am happy with this right here. This is sufficient. Okay, so you're asking, well, what might change about this equation that might make it insufficient? Right, what else would we have to do? Well, one thing would be maybe it's a negative, right? Maybe it opens in the opposite direction that we are thinking of, so you might have a negative out front. This one does not have a negative, but that's one thing that could happen. Maybe there's been some type of a vertical stretch, right? And we multiply everything by 2. Okay, so that doesn't change the fact that we have an intercept or an asymptote or anything like that. Right, we'd get the equation 4x minus 2 over 2x squared plus 4x minus 6. Right, that could also be an equation that has these same attributes. Right, but we would have to know some more about it in order to say that that's true. So I am just fine using our 2x minus 1 over x squared plus 2x minus 3. Okay, sounds good to me. Now our last one here, okay, let's figure out all of the stuff we need to find this one. X-intercept, does it cross the x-axis? Okay, I would say no, that this does not cross the x-axis, right? Because I have a question, where is the horizontal asymptote? Do you see a horizontal asymptote? right? No, we don't see one. So we can kind of assume that because it is in fact a rational equation, that there would be a horizontal asymptote going through the axis. Okay, if you ever don't see a horizontal axis or an asymptote, either asymptote, if you don't see an asymptote explicitly drawn on your page, then it probably goes through an axis. Okay, in this case, the x-axis. But if you're missing a vertical asymptote, right, if one is not explicitly drawn, then that could be the y-axis. Okay, so if you don't see one explicitly drawn, then assume that it goes through the axis. So we will not going to have, right, there's not going to be an x-intercept. So if there's no x-intercept, that means there's no x in the numerator. Right? It's just a number. So the most basic type of a function has a 1 in the numerator. So we're just going to put a 1 in the numerator. We're not going to worry about a 2 stretch or a 3 stretch. So if you don't have an x-intercept, that means you have no x in the numerator. Okay, your vertical asymptote is at positive 2. Okay, so we have x equals 2 as the vertical asymptote. So x minus 2 is going to be your denominator, x minus 2, because that's the equation that gives you a positive 2 as an asymptote. Okay, now the table is interesting. Notice that both of your asymptotic behaviors, right, both arrows are positive. Both arrows point up. Right, so there's no negative values for y whatsoever. So we have to think about what can we do to our problem in order to make there be no negative y values. Okay, so there are two things mathematically that we can think of. What if we take the absolute value? Right, absolute value makes things possible. So should we slap an absolute value down here? Probably not, right? That is a totally different kind of a thing. Absolute values graph to v's. This is, right, maybe not what we want to do. So what other operation do we know of that makes things positive? That would be squaring things, right? If you were to square any number, that makes something a positive. So it looks like we're going to be squaring your denominator in order to no longer have any negative y values, right? So all of our y values are positive. So we have done something to our graph or to our equation in order to make it positive. And what we've done is we have squared both sides. Okay, so when we do that, we can go ahead and look at the y-intercept. Right, 1 over 0 minus 2 squared is 1 over negative 2 squared, which is a positive 1/4. Okay, so let's see if it crosses the y-axis at about 1/4. Yeah, I'd believe that's about 1/4. So I think squaring that denominator is exactly the thing that we need to do in order to make our equation match up with our graph. Okay, so once again, your answers basically come from your r for your roots and from the vertical asymptote. And then we verify with the horizontal asymptote and with your y-intercept. Okay, have fun writing some equations. Bye-bye.